11.2, simplify radical expressions.
How would you rate this on a scale of 1 to 10?
10 being the easiest or the hardest?
10 being the hardest.
It's probably like a 4 or a 5.
Okay, when did we do 11.1?
We did not. We were skipping 11.1. We may come back to it, but I need something that I can teach quick and easy so that y'all can have work to do. You can just lay it on my desk and I'll get it. All right, a radical expression is in simplest form if the following are true. No perfect square factors. Okay, so that would be something like 9, for example. Or 4, or 9, or 16. Okay. And I should say this, other than 1, because obviously 1 could be in there. Are under the radical. No fractions are in the radical. And no radicals appear in the denominator of a fraction. Okay, so 2 and 3 kind of go together. Okay, so this is going back to using the greatest common factor stuff, finding things that they have in common and pulling them out of the radical. We'll talk about the quotient property later, but for the moment, we're going to do the product property for radicals. So, if you have something like, that's weird, number 4, the square root of 48, okay, is 48 a perfect square?
Yes. No.
No, it is not, okay? So I want to see how I can break this up. So we're going back to our factor trees from when we did factoring in chapter 9. Okay? So we write down 48. Now, what are 2 things that make up 48 when you multiply them together?
12 and 4.
Okay, 12 and 4. Okay, now what breaks up 4?
2 and 2.
2 and 2. What breaks up 12?
6 and 2.
Okay.
Yeah. 6 and 6.
What breaks up 6?
3 and 2.
Okay, now is anything able to be broken down farther than that?
No.
Okay, so now we use what we call the buddy system. Okay? Buddy system. If it has a buddy, we can take it out of the radical. So, there are 2 2's here. I can take 1 out. There are 2 more 2's. So I can take them out. 3 doesn't have a buddy. Okay, he has no friends, so we leave him. we leave him inside. You think it's funny, but it'll help you remember. If he has no friend, okay, if he doesn't have his identical twin, okay, you can't take him out. He has to stay inside. So the answer would be 4 radical 3.
Okay, I hate factoring. So.
Real quick, I know we had a test Friday. I was not here Friday, unexpectedly. I have...
Is tomorrow the day you have the appointment? Or is that next week?
Yeah, that too. Oh,
Do you want to take it on Wednesday during study hall? Or you're not going to be here Wednesday either?
No, I'll be here Wednesday. It's just...
Is there a penny?
Wacky,
Can I have
so
that?
many quizzes and tests Friday. Plus the ones that we're having Wednesday.
No, it's like, oh, so-
and the ones I have to make up tomorrow.
You told me to give me a penny, and I said I don't have a penny.
I'm leaving in 15 minutes. If you want, you could take it if you're ready. You don't have to. Okay.
But I know we can't exactly push it Thursday.
That's fine. I don't care. I don't care.
Because I can disregard the Wednesday no homework thing just because
Yeah,
the situation.
that's fine.
Because I've been taking like 5 tests and quizzes.
Yeah, no, that's too much. Don't worry about it. All right, number 6, the square root of 72. Okay, is 72 a perfect square?
No.
Okay, so I want to break it up. What can I break it up into?
8 and 9.
Okay, 8 and 9. What can I break 8 up into?
4 and 2.
And 4 goes in, or breaks up into 2 and 2. Okay, and then 9 breaks up into
3 and 3.
3 and 3. Now, everything's as simple as it can get, right?
Yes.
Yeah, 2 is gonna be the loner.
All right, so I'm going to find the buddies. Okay? I have 2 2s, and I have 2 3s, and then I have a lonely 2 left over. So outside, I have 2 times 3, and then under the radical, I have the lonely 2 left over. So that is 6 square root of 2.
Is this like where it stops for what we're doing today?
This, and then we're doing a little bit more with it. But what we're doing is relatively, like the 2 things we're doing are relatively easy.
What babies did you teach the garden?
Yes, I have.
That's
My nephew.
Oh, I saw a baby planting
I know you
something.
did,
And I was
and I didn't know how to set up in my.
Not mine.
yeah, I was for a minute. I was like, what?
All right, number 8 is 4x squared. Okay, now we're getting some letters inside. But the principle of it is the same.
Alright, so it would be
So I'm going to just write down okay, actually, hold on. Back up. Is 4 a perfect square?
yeah.
Okay, what is it a perfect square of? 2. Okay, it's a perfect square because 2 times 2 is 4. It has a buddy. There's 2 2s. So I can take that outside. Now, the x's. There's x times x. That's x squared. That's a buddy. So I can take an x out. So my answer is 2x.
Wait, yeah.
Okay, if you feel like you need to see it as a tree, you can still do it this way. 4x squared. Okay, this factors into 4 and x squared. 4 factors into 2 and 2. X squared is x and x. So then you have buddy, and you take them out.
Are we ever gonna have ones with variables with it that aren't a perfect square?
You could.
How do we do that?
So, 14 is actually going to be like, well, no, it's not. Never mind. Brief pause. Let's do a modified 8. 8 modified. Let's say that it was 9x cubed. Let's do that. So it's a little bit different, but the same idea. All right, so is 9 a perfect square?
Yeah.
What's it a perfect square of?
3.
Okay, so I can throw the 3 out front, or if you like the tree, can do 9x cubed, okay? This factors into a 9 and an x cubed. 9 is 3 and 3. X cubed is x and x squared. X squared is x and x, okay? So, I had a 3, okay? That was a buddy pair, so I take one of them out, okay? With the x's, I have 2 and I have 1 left over, so I can take one of them out. Okay, and then under the radical, I have the one that's left over. Okay, you take everything out that has a buddy, but you only take one of them out. You only write it once, okay? So the buddy system only gets written once.
I am actually paying attention.
All right, 10. The square root of 32m to the 5th. All right, is 32 a perfect square? No. Is m to the 5th a perfect square? Okay, so I have 32m to the 5th. So this is going to split into 32 and m to the 5th. Okay? 32 factors into what? Yes. Yes, it does.
9 and 4.
Okay, 9 and 4. 9 is,
3 and 3.
wait, 9 and 4, hold on, it's 8 and 4. Brief pause.
Same thing.
8 and 4. I was like ready to roll with it. I was like, yeah.
2 and 4.
Okay, so it's 2 and 4. 4 is,
2 and 2.
okay, and the other 4 is also 2 and 2. Now m to the 5th, okay? It doesn't really matter how you want to write this. If you want to write it as m to the 1st and then m to the 4th, that's fine. If you want to do m squared and m cubed, it doesn't matter. Okay, again, you don't necessarily have to do this with the variables. It just might help you see it a little better. So this is m and m. M cubed is m and m squared. And then m and m. Candy. Nobody got it. Okay. I said M&M and I said candy.
Oh, wow.
I want some.
Me too. All right, so buddy system. Okay, I have 2 M's here. I have 2 M's here. This is a loner. I have 2 2's here. I have 2 2's here, and I have a lonely 2 left over. So outside, you write down one of everything that's circled. So I have 2 times 2 times m, and then inside I have the stuff that's left over is a 2 and an m. So outside, 2 times 2 is 4, m times m is m squared, so 4m squared times the square root of 2m.
Yeah. All I can think of is.
Okay.
All right, 12 is the square root of 50 times the square root of 18. Now, there's 2 ways that you can go about doing this, okay? You can, from the beginning, multiply 50 times 18 because both things are under the radical and they're being multiplied. Or you can break them down individually and then combine the stuff that's left over to make it a little bit easier. I like that option of leaving them separate until I get to the end. Okay, so I'm going to actually break down 2 things. I'm going to do 50 and then I'm going to do 18. Okay, so what does 50 break into?
10 and 5.
Okay, 10 and 5. 10 breaks into? Okay. 18 then breaks into?
3 and 6.
6 breaks into?
2 and 3.
All right, so now I need to figure out the buddy pairs that we have, okay? So I have the 5s for that one with the 2 left over. Over here, I have the 3s with a 2 left over. Okay, so I'm going to have 5 times the square root of 2 times 3 times the square root of 2. So I multiply what's outside together, which is going to give me 15. Okay, now the stuff that's inside the radicals, the 2 radicals, if they get multiplied together, I multiply what's inside of them, meaning that I would have the square root of 4. Okay, the square root of 4, however, is a perfect square, so what is that? 2. So it's going to be 15 times 2, which is 30. Okay, now, if you had recognized, okay, that over here there was a 2 left in each one, I could have buddy paired them like that. Oh, I have a smiley face. Because they're being multiplied, I can. Okay, if they weren't being multiplied, I could not. I'm really bad at drawing noses.
Well, I bet you can make that look great.
Just go like this.
Yeah, literally just draw 2 dots. Thank you.
It kind of looks like a lizard, like the little guy from Rapunzel.
Oh my gosh! Pascal.
Actually,
What are these for?
Junior, senior.
Oh, right.
His name is Pascal.
I know it's not
If you gave it 2 dots, it would be.
All right.
You also got 2.
My meds are wearing off, so I'm like every way today.
14.
Don't worry about it.
He does this. This is
The square root of 3b cubed times the square root of 18b.
Alright, see, this is unfair.
Okay? So, here's what I'm going to show you a little trick. Okay, these are being multiplied, meaning that everything underneath can be multiplied together. So I could rewrite this as the square root of 3 times 18 times b cubed times b. Okay? Now, there's really no point in me multiplying 3 times 18 because I'm getting ready to break it down into smaller pieces.
54.
So, I can just do this. I don't care what that number is. Doesn't matter. I'm a little person again. It's like a dog nose. Okay? And then I have b to the 4th, okay, getting broken down, okay, which we already had was b cubed and b, so I can break that down, okay? So, 18 breaks into what?
3 and 6.
3 and 6.
Say 9.
6 breaks into
2 and 3.
2 and 3.
Sir.
Then over here, I can break these down into b squared and b, and then b and b. So, buddies, I have a set of 3s. I have a 2 and a 3 left over. They don't have a buddy, so I leave them there. Over here, I have 2 b's and 2 b's. So, outside, I write one of everything that's in the circle. So, 3 times b, and then the square root of whatever's left. I had a 2 left and a 3 left, so that's 2 times 3 inside. Okay? So, this gives me 3b squared times the square root of 6. Not too bad, right?
Pretty easy.
No. It's not easy. Still writing super easy.
I just don't like all the letters. But I mean, this is
Or-
one
or-
part.
You don't cheat this one, you're writing.
Did you cut your hair?
Yeah.
I like it.
Thanks.
It's like a businessman.
Everyone's like in the middle too much
All right.
hair.
They did.
Middle part, you know?
Melcher can't rock the middle part like I do.
Yeah, Brandon rocks the middle part.
Yeah.
Someone needs to just, like, take
I've had to for 4 hours today.
I'm so sorry.
4? You have him for 4 classes?
Well, I have him for 3, but I have my stats kids coming in at 7 every day until their exam to study.
Oh yeah, so they get that like 2-week free period. That's what's
So you better look at that hair for 4 hours. I'm so sorry.
Thank you.
like
See, Brandon, it doesn't look bad. if-
No, it's fine.
I look to go with the middle part, but I don't have it
You can still go like that.
All right.
James, the middle part.
Last one for today. And then y'all are getting problems to do and going to Miss Patton's room and being very, very quiet because I'm pretty sure she'll pinch your head off if you don't.
I have this pattern for the 3rd time today.
Because that's how Melcher is every day, but it's back to back to back.
2 of my classes are back to back.
But she said if they talk, they can't stay.
So I
So
have
if you
an
see
idea.
someone-
So don't talk.
Or
These are doing
talk and then I don't have to stay.
And get your head pinched off by Miss Patton.
She's
I like
I'm
it.
gonna try. Whoa.
All right.
8 and 8.
Now, before you go any farther,
Yes, ma'am.
64 breaks up into 8 and 8. Now, is there a reason for me to keep going?
No.
No, because ultimately I'm going to end up multiplying it all back to give me that buddy gives me an 8. So I can go ahead and take it out. If you recognize it was a perfect square without doing the tree, just take an 8 out. Okay, but now I have the s to the 4th and the t cubed. Okay, so s to the 4th would be s squared and s squared, which is s, and then s and s. And then t cubed is t squared and t, which is t and t.
Ooh.
So I can take out a set of s's, another set of s's, a set of t's, and then I have one lonely t left over. So 8 times s times the square root of t, or wait,
What about the other T?
I did leave out the other t, times t times the square root of t. There we go. I'm like reading across trying to make sure I get everything.
24/7.
Alright, so this gives me 8 times s squared times t times the square root of t. Cool? Alright, so I want you to do, making sure you have plenty to do so there's no reason for you to talk in her room. 3 through 17 odd.
Okay.
I think I'm actually kind of comfortable with this.
Yeah,
I'm
I
not
think I'm
gonna-
good with